So I know there's been some confusion on the perceptron learning, so I'm just going to do this really quick, and hopefully this helps and isn't, well, hopefully this helps, yeah. When we're talking about a perceptron, it's like the most basic of basically like machine learning sort of, and we're going to go over the example of like the one layer. There's like multi-layer perceptrons where you can create superior boundaries, but like the one layer is just like a line in two-dimensional space where you have your predictors. So in this case, x and y are our two predictors. And if we have some classifications, whether this be 1 or 0s, and it's positive or negative, and we have some set of parameters x and y, then we have this line. And so this is the thing we're trying to train. We're trying to find, and of course there are multiple lines that work, so you may not have one answer necessarily. And then we can do the same thing in three-dimensional space. And again, it only has two outcomes, so we still only have pluses and minuses, or 1s and 0s, or whatever. But now we have 3 variables, and so we would form a plane. And if you have 4 variables, you're forming a hyperplane in three-dimensional space. So I'm going to go over one of the examples he did in class really fast for anyone who missed it or got lost, because that's understandable. So basically you have like your 3 predictors, and then you have a classification. So our classification, the ones he listed are plus, minus, plus, minus, minus, plus, and then we have 3, 5, 1. And so these are like coordinates. These are coordinates of where these classifications are falling. So then let's see, 1, 3, 1, 6, 5, 8, 4, 1, 11, and 2, 7, 2. Now, when we look at this line, this is going to be important in a second. We have y is mx plus b. That is our line. So when we are looking at this b, and the examples he's given, they've all basically been 3 predictors. So we've had an x, y, and z. You also have this b, and so essentially to find this b, because what our goal is going to be is to find the weight vector that can predict the x vector. So in order to have this b, we have to add a weight, and because it's a constant, we're just going to add 1. So when we start writing copying over our setup, so this is our setup, we're going to copy over our setup, so we have 3, 5, 1, and then we're going to add this 1 column, because that's representative, this is representative of our constant. And then we're going to have a weight vector. So this weight vector is our perceptron. We're trying to train this boundary that separates the pluses or minuses so we can predict future ones, basically. And then that is going to give us some value. And then we potentially have an error. And then we have basically our adjustment, or whatever you want to call that. So we have like our adjustment options. So this is an example he did in class. So I have the numbers in front of me on another screen, and I'm just going to kind of go through it a little quick, but so basically what you're going to do is you're going to choose some random weight vector to start off. So it's like hill climbing in the sense that we just start off with a random weight vector, and the one he happened to do was 0, -1, 0, 1. And so then we're going to do the dot product of our x and w. So we're going to take the dot product, which should give us just like a single integer value, In this case, it will give us -4. So you take, in case you forgot or something, it's just like 0 times 3 plus -1 times 5 plus 0 times 1 plus 1 times 1 gives us -4. And then what we're going to do is we're going to inspect this vector. So we have this vector here, the 3, 5, 1, and we expected positive, but here we got negative. And in the example he just sent out, he's using like zeros as the negative, which is kind of confusing if I'm being honest, and ones as the positive, but similarly you'd have classification. So you expected a positive, and in this case you got a negative. So did we have an error? Yes. And now we're going to make an adjustment. So what we're going to do is we're going to take the weight vector, and in this case, I expected a positive and I got a negative, so I'm going to add x to my weight vector, and that's going to give me 3, 4, 1, 2. And so this becomes my new weight vector down here, so 3, 4, 1, 2, and then I copy down the next x vector, which is 2, 4, 9, and then we add that 1 for the plus b. And then that's going to give us, if we do the dot product, that'll give us 33. And oh, it's positive. That's good, except this one we're actually expecting negative. So we have positive, we wanted negative, so now we need to adjust again. We have error, we need to adjust again. So we're going to subtract the x vector from our current weight vector. So 3, 4, 1, 2, we subtract x, we get 2, 3, minus 7, 2. Okay, and then we're going to use this weight vector on our new, on the next thing from our x. And the x is like data points, just to reiterate. It's like solid data. We're not guessing about that at all. So this is like given to us. And if we do that one, we get -6, but again, we expected positive here, so we wanted positive, we got negative, so we have error again. We're going to have to do the difference. I'm sorry. I was copying it down and I skipped a line. So if you're very confused, this actually should have been 1, 0, -8, 1, and then here. Sorry about that. So this will give you -6. This vector should actually, I should have actually been checking that at least a little bit. My bad. So now this will give us 2, 3, -7, 2. And then we plug in the next vector, which is 6, 5, 8, and then that 1 for the plus b, and we have our new vector, and it's 3, -7, and 2. And if we do that dot product, we get -27, and we're expecting a negative, so this is the first time that we have no error. And since we have no error, we don't actually have to make an adjustment. So we're just going to go down and we're going to copy down the through 2, 3, 7, 2 for the next one, which is 4, 1, 11, 1. That's going to give us -64, I think. And then this is error, no, because we expected negative, right? We've got negative, negative. We don't have error, no adjustment needed. We're going to copy 2, 3, 7 minus, or 2, 3, -7, 2. And then the last vector, 2, 7, 2, and 1. And then we're going to take that dot product, and that gives us 13, which is good because we wanted a positive on this last one. So is there error? There's not an error. We don't have to make an adjustment. So then what you would want to do to make sure that this weight converges is you'd basically want to do it over and make sure that these three are all true, like they don't get error over here. As long as you end up with 6 ends in a row, basically, then you have a weight that you have a solution. Because remember, you can have multiple solutions. But he mentioned that he's probably going to have us only do one epoch. And so going through this whole list once, is basically one epoch. So this is the first epoch, and then basically if we were to keep going, we would have a second epoch. But I'm pretty sure he said he's only going to have us do one epoch for the exam. But you'd start back over. If you did have to do it, you'd say 3, 5, 1, 1, and then you'd keep that same weight from before, and I think that one comes out to like 10, and then it's supposed to be positive, so there's no error. I think actually this weight vector is a solution for this specific problem. So that's basically Perceptron. I hope this helps. Sorry about that mistake in the bit metal.